chat, and let's see here. All right, so I got a couple of slides for today for status updates, but not a whole lot new to report. So for those of you who are on the mailing list, I sent around a, well, I guess relatively long email, basically covering all of the commits that have been pushed up to the main Corundum repository. So that's taken care of. So that means anybody that was using my my fork of the repository, well, you can now just use the main Corundum repository because all of those changes have been pushed over there. It's mostly incremental stuff, nothing particularly huge or disruptive or anything. The disruptive stuff is going to be coming soon. So, all right. So yeah, the agenda for today is I basically just have the status updates, and then depending on who's connected and what people want to talk about, we can discuss other stuff. So we'll see. All right. So last time I talked about all this address space abstraction stuff that I was working on. So that's all now done and committed and finished. So that can now be used inside of the the test benches in Corundum. And the next thing that I'm going to be working on is the shared interface data path, which I discussed a little bit previously. The idea behind this is to make the design a little bit more efficient in terms of being able to reuse some of the control logic in the data path. And then a number of other things that I've kind of reordered a little bit that also need to be done. So this is what I'm going to be working on over the next few weeks. So anyway, quick recap on the address space abstraction. We've added the address space abstraction objects to the CocoaDB components, both AXI and PCIe. And this basically supersedes the kind of basic region handling in CocoaDBX PCIe and provides a more general setup for doing that can be used for many different extensions, many different components. So the idea is to emulate SOC style address space, where you can have multiple components that talk to each other through this abstraction. And at this point, it's done. All of the CocoaDB extensions have been updated, and the driver model for Corundum has been updated to use this abstraction. And I've also added support for AXI. So you can create, if you have a Corundum design variant for AXI, then you can attach the AXI master for performing register operations, as well as an AXI slave, which will allow the design to perform DMA operations against simulated host memory or other devices. And then the driver model can utilize all of this. So yeah, so right now I have basically two different init methods, one for basically connecting to a PCIe device and one for connecting to some other kind of device. More specifically, it's designed for AXI, but ostensibly you could use it for whatever. I also have AXI core logic committed to the repository, so that's going to facilitate getting this thing running on the Zinc MPSoC, which the folks at MLE have been working on. All right, so that's the address space abstraction. That's done. That's committed. The next piece that I'm going to be working on, I've been working on it over the past week, not quite done yet, is the shared interface data path, where we're taking all of the data path components that are associated with the ports, and we're moving those into the interface. So as a result, each port is only going to have a transmit scheduler and transmit and receive FIFOs. That's it. Everything else ends up in the interface. So this simplifies the implementation a little bit. It also means that the application just has a single AXI stream, input and output connection for all of the transmit and receive data for all of the ports on each interface. So each interface will have its own, set of these AXI stream ports, but you won't have to, multiplex across, all the ports if you want to do something at the interface level. This also supports things like traffic class for prioritization, priority flow control, etc. Well, eventually it'll support that. I need to do some more work in the FIFOs, but that long-term goal is to make that work. And I also need to implement some internal flow control to alleviate headline blocking, because when you have one high-speed data path feeding multiple lower-speed ports, you have to make sure that you don't overflow the transmit FIFOs, because if you do that, then the entire thing is going to get all backed up. So over the last week, I've been working on kind of the reorganization part of this by pulling all of the stuff out of the port module. And I think the port module is actually going to go away completely. And the code that was in there is going to end up in several other modules. Most of it is ending up in the interface module, either directly or indirectly. So there's I'm adding a couple of additional modules to make things a little bit nicer from an organizational perspective. I added transmit and receive FIFO modules. I added transmit and receive, ingress and egress pipeline modules. I also added modules to contain most of the transmit and receive data path code. So instead of having one gigantic module, we now have several slightly smaller, easy to work with pieces. Well, easier to work with, I suppose. I don't have that committed yet because it's not quite finished, and I need to I've been making a couple of changes to the AXI stream components in terms of managing, routing information and IDs and whatnot. So once I get all that merged together and get it working with multiple ports, then I'll go ahead and push that up so people can start hammering on it. So yeah, I got to get multiple ports working. I got to get internal flow control working, and then I also need to implement the shared memory FIFOs. So I was going to do the shared memory FIFOs first, but then I had an epiphany. I'm like, we don't really need to implement the shared memory FIFOs. That's kind of an optimization. So what we can do is just use the existing FIFO and with the converter and multiplexing and demultiplexing components and do the same thing functionally. And that might be what you want to do under certain circumstances anyway. So instead of going straight for the shared memory FIFO, going to put something together with some of the existing pieces and potentially have several different implementations that you can switch between depending on how many ports you have, how many traffic classes you have, and whatnot, and what FPGA you're running on. Maybe you want a particular configuration because it'll make more sense from a resource consumption or performance standpoint. Actually, it should be any difference from a performance standpoint. So mainly from a resource consumption standpoint, what's going to make the most sense. So yeah, that's what I'm working on. And like I said, the kind of high level reorganization is mostly done, and I have this working in simulation with a single port. So I need to extend that to multiple ports with handling the the various IDs. So as part of this, I do need to change the interface into the application section. So here's just a little overview of what that's going to look like. We're bringing on the TID and TDEST signals, as well as some additional bits in TUser to make all this work. And this is going to affect basically one of the three sets of AXI stream ports going into the application section. So the MAC direct and the MAC synchronous, no changes there. This only affects the interface level connections. So instead of having one connection per port, so if you have 2 interfaces and 4 ports per interface, you would have 8 of these previously. Now you would only have 2. And the way this is going to work is we're going to use the TID and TDEST signals along with a couple bits in TUser for routing and bookkeeping and whatnot to make everything work. Okay, so in the transmit direction, the TID is going to carry this ID of the source queue. So you'll be able to, from the application section, see what queue things are coming from if you want to, implement different rules or whatever based on the source queue. And then the TDEST field will contain the destination port and traffic class, probably like lower 3 or 4 bits for the traffic class, and then the higher bits for the destination port. And this one will make the determination of which transmit FIFO the packet ends up in. And then in the TUser field, we're going to have some tag bits that are used for flow control purposes, and also for associating the PTP timestamp with the original packet. Haven't quite. So right now it's set up for PTP timestamping. I may need to make a couple of tweaks for this to work for the internal flow control, because that'll need to be needs to be peeled off and returned somewhere somehow. So I don't have that totally figured out yet. Maybe I'll just fake the PTP timestamp basically. So it's always using the same path, but it gets turned around before the Mac if PTP timestamping is not being used. This is necessary to release the internal flow control credits. So one thing I need to figure out as well is what happens if the user logic wants to either duplicate a packet or drop a packet. One thing you're going to have to do is, if you're generating packets from user logic, you'll have to make sure to generate tag bits into user that are not going to cause the transmit data path to do the wrong thing in terms of freeing up transmit credits for something that hasn't actually been sent yet. So there's some details that need to be figured out, but that's kind of the idea on the transmit side. On the receive side, the TID will carry the source port, and the TDEST, I'm thinking, is going to carry the destination queue. So if you wanted to do some sort of a flow steering thing in the application section, then you could compute the destination queue that you wanted, put that in TDEST. But I'm thinking that's probably not going to be quite sufficient, because the RSS module is going to sit on the data path side. So that will handle the packet after it goes through the application section in the receive direction. So we'll have to have some way of informing the RSS logic to use the TDEST instead of computing a new destination queue. And then in the receive direction, we also have the TUser field. Currently, this carries just the PTP timestamp, but we may need to extend this with a couple of additional bits, potentially for controlling RSS and determining which queue is going to be used to receive the packet. So this could be as simple as just one bit saying allow RSS to compute the destination queue, or set it to override use a TDEST value. That's potentially an option. Another option, maybe perhaps we want to set few bits and let RSS compute the other bits. Not sure. So it's going to require a little bit of thought. I may need to add a few additional bits to user, but this is kind of a a preview of what's going to be coming. And then what I'm going to be working on after this are variable length scripter support and phi CSRs and a few other things which I've talked about before. I don't have much else to show for these because they've been kind of on the back burner. But yeah, just to recap, variable length scripter support, this will improve the performance, hopefully, and allow you to do some more interesting things with the in terms of interfacing with the core logic. And phi CSRs, these will provide more direct control and status reporting over the over what's going on at the port level. 10G 25G switching, this will allow you to dynamically switch between the ports running at 10 gig or 25 gig. And that brings us to the to-do list that I've put together for the stable release. So application section, that's implemented. The shared interface data path, that's what I'm working on right now. Then we have a few other points before we'll be able to actually start versioning stuff properly. Right. Oh, I guess one other thing that I should mention is that with the shared interface data path, I do need to move around a couple of registers. So once I start committing this to these modifications to my fork of Corundum, then you'll have to make sure you're using the appropriate driver version. Otherwise, you'll get some unexpected results. Once we get the register space reorganization squared away, then we'll actually have a better way of versioning things. So it should be possible to make things more forwards and backwards compatible. But that's more of a down the road kind of thing. Once that's implemented, then we'll have some more control and some more flexibility. But in the meantime, we're kind of stuck with the current setup, which doesn't really have any provisions for versioning. So yeah, kind of a we'll tear the band-aid off kind of approach. But yeah, hopefully it's not going to cause too many problems because this is still very much under development. yeah, that's how things are looking like going forward. All right, so at this point, people have any questions? I guess we have a relatively small group today.
Yeah, I guess just a comment regarding moving around registers. What about just updating the device ID so that it simply won't match anymore, so nobody gets into any surprise?
Yeah, I guess we could just start incrementing the device ID. I don't know, kind of a dirty solution. I mean, my kind of thought is that yeah. Yeah, I mean, I guess that would work. I guess since we're kind of using a you know, unallocated ID at the moment anyway, we could probably do that. And then once we have an allocated one at some point, once we have stuff more finalized, then we can just move over to that. Well, I guess there's also the like the revision code, right? There's also a field in the PCIe headers, the revision. Potentially we could use that one too. Not sure.
Yeah,
I'll do some
right.
thinking over that. Yeah, I mean, I guess the problem with something like that is that the current driver doesn't look at any of that. It just latches onto the device ID. So I don't know, maybe a combination of both. We can increment the device ID and then add some code to the driver to check the revision ID.
Yeah.
And then once things are finalized, you know, maybe bump the device ID once more and reset the division ID or the revision ID. Yeah. I don't know. I'll think about that, but yeah, that's a good idea. Well, did you guys have a chance to work on the Zinc support at all? Because I think,
Unfortunately, not yet. It's
okay.
on the to-do list, kind of the next item for me or a colleague, most likely.
Okay. Yeah, because I know
so
we were running
we will
into
get
I know
into
you guys
this.
are running into a bug with that. We'll have to get to the bottom of that.
Yeah, right. It's I think it should be reproducible in simulation too. It's rather easy in on real hardware. Just have to start kind of two pings from both directions, or simply UDP based iPerf from both directions. Then it freezes rather quickly.
Right. Well, it's reproducible in hardware. That doesn't necessarily mean it's going to be easy to reproduce in sim, right? Because you're running obviously a different device driver in hardware than in sim, where we have just a driver model. So potentially it could be some sort of a, you know, concurrency issue with something in the driver, potentially how interrupts are handled or something else. Not sure about that. Another possibility could be that it has something to do with kind of the SoC hard logic, right? Something on the AXI side, something about what the AXI interfaces are doing when, you know, Corundum is trying to perform DMA that's tripping something up. And if the simulation model doesn't capture what the SoC is doing, then you're not going to be able to reproduce
right,
it.
yeah.
So unfortunately, I think to this one, we're going to have to do a bit of work with the ILA on. But potentially what we can do is figure out if there's some sort of a trigger condition that can be generated that can then be used to trigger the ILA. So when things hang, sometimes there's a way you can put some bits and pieces together and generate a trigger for the ILA. Because you don't have very many samples to work with, right? That's kind of that's kind of the trick with the ILA. You got to have some idea of what you're looking for, otherwise you're never going to find it.
Yeah. That's always the problem.
Yeah, I've had to hunt down a number of hanging related bugs in Corundum, and that's one of the techniques that I used was um, kind of figuring out what happens when it's hung in terms of which signals are getting stuck in the wrong state or whatever, and then based off of that you can basically set up a counter, and if those signals are in that state for a certain length of time, then you can use it to generate a trigger signal for the ILA, and that
Right.
that
Yeah.
was pretty effective at locating a few bugs.
Mm,
So we made it
right.
to do something similar. Not sure
Yeah.
about that.
We'll see. I guess we start with the simulation since it's now there,
Right,
and
yeah.
see
Well, the
how far we
simulation
get.
runs a whole bunch of back-to-back packets at a couple different sizes. So it seems to me like the simulation should show what's going on. If you have traffic going in both directions, that's what the simulation is doing. But
Yeah.
it ran to completion. So
Yeah.
that's unfortunately a little bit inconclusive, but it's at least running now. So yeah, we can certainly poke at it. I guess one thing it doesn't do is any sort of reordering on the AXI side for DMA operations.
Okay.
Although I don't know if if you see much reordering on the SOC. I'm not sure about that.
Yeah, I'm
That might
not
be
sure
something
either.
to look into. That's one thing I was scratching my head over, is that with the with AXI, it's not allowed to reorder if the ID fields are the same. So from the standpoint of a memory, I'm not even really sure how you would handle that. Because if you have like a 16-bit ID field, I don't think you're going to have 64,000 different queues to maintain ordering in. So I don't know. One option is just, if you don't do any reordering, then it's not a problem. So might need to take a closer look at the documentation to see what's going on there.
Yeah.
Sorry. Can you hear?
Yeah, sure.
Yeah, I have a thing. I just want to ask about what you said reordering in Sync SOC, because I am working on a device based on Sync SOC too.
Oh, you are? Okay. So you're hoping to run, well, okay, so with the Zinc SOC, I guess you can run either over PCIe to a host, or with the Zinc as the host. So are you using the Zinc as the host? Sounds like it.
No, not now. At the time now, I'm using the server as the host, and
okay.
only the PL part. And I am now struggling.
Right. So you're ignoring the SOC part of it, right? So in that case, things should work just fine.
Yeah.
Yeah, because the folks at MLE are trying to get it to run on the Zinc with the ARM cores as the host, and communicating over AXI instead of communicating over PCIe. So that changes the picture a little bit. Have you tried running Corundum on your board, or are you having issues with that?
Now is I have tried. I have ported the Corundum to the board. The board is manufactured by a company named Resnick. Maybe you didn't hear about that.
What did you say it's called? Resnick?
Yeah, the company name is a Chinese company.
Okay. Yeah, I have not heard of it, but I'd be happy to take a look. So it says Resnick, RESNIC?
RESNIC.
I don't know, if it's a Chinese company, I might not be able to find it,
I want to ask a problem you might be faced with the sync SOC. That would be the problem. Maybe I will make in future.
I found it.
Oh yeah, I found it as well. I guess it's resnix, resnix.com. Okay, so they have a couple of
It's
different
Resnix.
devices.
Yes,
Okay,
there is
yeah.
S.
I guess they have a couple of different variants. Yeah, so there's a there should be a reference design in the repository already for the ZCU 106 board, right? And that one works just fine because it's just using the you know, one of these guys, because that just used the programmable logic side PCI Express. And I guess if those boards are using a lot of, it looks like those might be 16-lane boards. It seems like you might be able to take, I'm not going to say any of the 16-lane designs, but you know, one of the 16-lane designs and drop it on that, and it should work. You just might need to make a couple of modifications to the, you know, board level code.
Okay.
But yeah, if you run into any issues porting that, you know, you're welcome to post on the Slack or mailing list or whatever and ask. Might be able to help you figure out what the story is. So you said you're working on porting it, but you haven't actually tried running it on the card yet?
I have running the Corundum, both 100 gig and 25 and 10 gig.
Right. But have you tried running it on the card yet? Does it work there?
Yeah. I have tried. Just the speed is quite low. It's about 13, 20 or 13 gig.
Right. Well, so you can run into issues with the Linux kernel networking stack kind of limiting how fast you can run. So running the card up to, you know, hundreds of gigabits to 100 gigabits per second requires some special care in terms of generally running a lot of stuff in parallel in order to get that kind of speed. It's also dependent on what the host CPU is. You know, when you have a 100 gig design, it's almost more of a test of the host system than it is of the NIC itself.
Yeah, I know that.
All right, does anybody else have any other questions? Oh, I see Ulrich has joined us from MLE. Not sure if Ulrich has anything he wants to add.
Hey, sorry, I just joined, so I didn't get all the discussion.
Oh, okay,
Sorry.
okay.
Had some stuff going on at home here with an electrician stopping by.
Oh yeah, no worries, no worries. Yeah, not a whole lot in terms of updates for this week on my end. Mainly just I'm working on the initial version of the shared interface data path stuff. So I guess I can put that slide back up if you want to take a look. So I know you guys were going to be doing some work with, or that was one of the features that you guys were interested in. So let me see about sharing this.
But if you already provided it, so I can just review the recording.
Yeah, but I mean, you're on now, so you know, if you have any questions about it or anything, then now's the time to ask instead of having to schedule a follow-up meeting, right? Let me see here. All right, so shared interface data path over the past week, I basically decided to, you know, pull the guts out of Corundum and reorganize it and do kind of the first pass implementation of the shared interface data path. And that's currently working in simulation. I haven't committed it yet because there's a bunch of little odds and ends I need to kind of polish a little bit. But progress is being made on that front. So right now I just have it working with a single port in simulation. To do is multiple ports and internal flow control, and also to implement the shared memory FIFOs that are going to be more useful for things like traffic classes. But the big component for the shared interface data path, probably one of the bigger changes that people might run into is the interface into the application section is going to be modified a little bit. So we're going to be bringing on a couple of the sideband signals, TID, TDEST, and TUser for both the RX and TX. So I think right now, I know right now in the current setup, RX TUser carries the PTP timestamp, and I think the TX TUser, it has some bits for a PTP timestamp tag, but in the current design, they are not used. But those do need to be used for the shared interface data path. So the way it's going to work in the transmit direction is the TID in the transmit direction will carry the source queue ID. So you'll know, from the standpoint of the application logic, what queue that packet came from. And then the TDEST field will carry the destination port and traffic class. Probably the traffic class will be the lower 3 or 4 bits, something like that. And then the destination port will be everything above that. And the TX TUser will carry a tag, and this will be used for flow control purposes internally, as well as associating the PTP transmit timestamp with the packet. So that the idea is that will be returned through a separate PTP timestamp path from the Mac. And then if you're using PTP, then that will provide the PTP timestamp for that transmit packet. Otherwise, it'll be used for releasing the internal flow control credits associated with that packet. So we may need to do a little bit of additional work, if the application logic wants to duplicate or drop a transmit packet. We may need to potentially modify the contents of some of these fields and potentially inform the transmit path, that a packet is being dropped, so that it can release the flow control credits and whatnot properly. Right, and then in the RX direction, we have kind of a similar setup. The RX TID is going to carry the source port information, and this will be included in the transmit descriptor, or in the receive completion rather. And then in the RX direction, I'm thinking for TDEST, we're going to put the destination queue, and this is still somewhat TBD because after going through the application section, the packets will pass through the RSS module, which will compute the flow hash and potentially compute the destination queue. So I think if we put the destination queue in TDEST, we're also going to have some other bits that can tell the RSS module, what to do. If we're going to use the TDEST versus the RSS hash for computing the the destination queue, or if we're going to do like some sort of a mask operation where we'll use some bits from TDEST and some bits from the RSS hash computation. Not sure about that. Probably needs a little bit more thought, but we may need to add a couple of additional bits to TUser as part of that. So right now the TUser just carries the PTP timestamp, but potentially we'll have to add a couple additional fields for some of the other purposes.
So the idea of carrying this destination queue is basically that's what TDEST is used for, and how to interpret this will be placed in TUser, right?
Right, that's kind of what I'm thinking. Yeah.
Okay. Mm-hmm.
So this allows you to send packets wherever you want from the application section, which I think a few people have been asking about. So
yeah, right.
That's kind of
I guess
idea.
we discussed this last time, right?
Right.
Okay. Yeah, makes sense.
And
I
I'm
guess
certainly
that was
open to
our
making
conclusion.
I'm certainly open to making some modifications to this if you guys have some potentially better ideas for how to simplify things.
Well, I guess, yeah, no. So we were thinking that it makes sense to really enable a combination of application-based queue steering and RSS as well. So I guess that's the complexity we are looking at.
Right.
Yeah. And
well,
especially that's one of the items where you can leverage the large amount of queues present in Corundum, right? So
right.
So we should take advantage of this one.
Right, yeah. I mean, that's for our use cases, at least, we need a lot of transmit queues and we don't really care too much on the receive side, but I can definitely see the benefits of using, you know, one queue per connection or something like that. And if you're doing something along those lines, you know, then you're really going to need to be doing a lot more work in the application section to determine, you know, which connection is this packet a part of, and then get it back in the appropriate receive queue. So
exactly. And if one connection scales, you may want to use multiple CPUs to process it, and then you want to have more than one queue to target it to. Depends on whatever connection is. So for a TCP session, it doesn't make sense, but for other items, it may.
Right. I mean, I guess it kind of depends on, yeah, exactly what the format of the data is and whatnot. Like if you have a TCP style connection where you want to maintain the ordering and whatnot, maybe it doesn't make sense. But for, you know, UDP, where maybe you're handling individual messages, you might have, you know, kind of separate flows or streams or something like that, sessions. Maybe it makes sense to try and, you know, demultiplex some of those across multiple queues, do some load balancing or whatever. But yeah, the idea is to allow the application section to, you know, have some control over that.
Mm-hmm. Yeah, I guess that really makes sense. And yeah, that's a version that yeah, why not doing so? Okay.
Yeah, I think this is really similar with what we are trying to do. Like I'm also working on the project doing request scheduling on the RX path.
Right.
So yeah, so like for RSS, it's just a flow hash. But what I'm doing is request scheduling, so I have more flexibility to schedule requests to different CPU core, to load balancing them and schedule the order of them. Yeah.
Right. You know,
I
perhaps something
believe
that's a little bit
is-
more aware of what the application is doing, so you can make a better
Yeah.
scheduling decision. Yeah.
Yeah, I mean, this depends on the affinity you want to achieve. Like for TCP, you have strong affinity to maintain the order within a flow, but for some RPC requests or application-specific requests, you have the flexibility to reorder them, and you have more like flexibility to do load balancing or scheduling.
Right. So it might make sense to shunt things to a different core if one core is busy. Yeah. Yeah, that makes a lot of sense. Yeah. So I mean, if you have any input in terms of, you know, what this looks like and what capabilities that you need, it sounds like you basically just want to pick the destination queue yourself and skip RSS, right? Yeah. Okay. Yeah, it sounds like there's kind of at least three different use cases. There's kind of three trivial ones, right? The first one is, well, there's two trivial ones, right? The first one is, you know, you let RSS do its thing. The second one is you let the application do its thing and you know, ignore RSS. And then the third is some kind of hybrid between the two. And, you know, the simplest thing to do is to have some sort of a mask, basically, where RSS can pick some of the bits and then TDES can pick some other bits. The question is, you know, does it make sense to do that on a packet by packet basis, or does it make sense to implement that, you know, on some other level? So.
Yeah, makes sense.
All right, well, that's all I got for today in terms of updates. So if people have questions or things they want to discuss, then, you know, we can do that. Otherwise, if there's nothing else, then we can probably end this meeting early. We'll be under time for once, unlike last week where we went almost an hour overtime. Nothing wrong with going overtime. I don't have any conflicts, but you know.
I had one thing to say.
Okay.
Maybe it's not the best thing to show, but maybe one day, if we have enough time, can you show how a typical packet enters from the port and what things happen to it until it reaches the CPU at that time? I mean, for a design at that time.
Okay,
Did you
so
understand what I mean?
just kind of an overview of everything that takes place.
Yes, yes. When you want to send a packet, for example, when the packet enters, it passes through it gets decoded and then pass to other parts of the design, and something like this happens and goes to DMA, goes to CPU after this process. Can we show like this diagram and talk on that?
Did you see, I posted in Slack a while ago, at least I think I posted in Slack a while ago, a document that I'd written up like a year ago or something that just had a huge list of everything that takes place during transmitted, during receive. Did you see that?
Yes, it's about optical switch and Corundum, right?
No, this one actually had nothing to do with optical switching. It was just a okay, here we go. I think I found a link to the post here. I'll go ahead and see if I can get a link to this that I can send you. But yeah, it's just a text file that just lists out all the steps.
Nice. Okay.
I think that'll pull it up. Let me know if that doesn't work.
Let me check. Oh, it asks an email or something.
Oh, are you not on the Slack?
No, I'm not there.
Okay. Well, you should join then.
Okay. So
Let me
I'm
see here.
copying the.
Yeah,
I'm copying the link.
if you have a join link handy. I have a join link on one of these windows here somewhere. Let me see here. There we go. Okay, copy and all right. There you go. That should allow you to join the Slack. It's right at the top of the README. I think we have a slightly different group of people on the Slack versus on the mailing list.
Yes, I think because one example is I have one example.
Yeah, but that file lists out, at least for a slightly earlier version of Corundum. I think there's been a few things that have changed since then, but it's at least an overview of everything that takes place, with a little bit on what's going on in the driver and a little bit of what's going on in the actual hardware. So there's something like 100 steps for
it's
transmit
like
and 100 steps for
snapshot of
receive.
last year or maybe few months ago. All right.
Something like that. Yeah. One of these days I need to update it. But there's a lot of new stuff that's being implemented and things
Yes,
modified and moved
that's
around
why
and
I
whatnot, so-
asked.
Right.
Okay, but even I think it's better if I understand this, and maybe one day there will be a new document and we are going to see that. Thanks.
All right. Well, does anybody else have any questions or comments, or shall we go ahead and end the meeting here?
Well, maybe just a status from our side.
Sure.
And so there is still open, I guess, the integration or testing more or less the MPSoC port, so the AXI DMA interface port. So now that we have a test bench, I guess the next step would be to reproduce what we see in the reality into the test bench, because we still see this issue happening that I guess Joachim reported earlier.
Yeah, we just talked about it before
Okay.
you joined. Uli.
Right.
That
yeah.
was
Okay,
also
sorry.
the only point.
Yeah, so I mean, I think
we
the
can
story
skip
with
this
that
one.
is it's unclear whether it's going to be easy to reproduce in simulation or not. So I mean, the nice
Yeah.
thing is that it seems like this hang is pretty reproducible in hardware. So, you know, it should be pretty easy to check to see if you're still running into the issue or not. But it's unclear. The problem is whenever you have something like that in a big complicated system, it could be coming from any one of a number of different components or interactions, right? So
Oh yes.
it's possible that it could be like a driver problem. And since the test bench uses a driver model and not the actual driver, potentially there could be something going on there, or it could be, you know, timing related, which, you know, you're not going to see that in simulation because of the difference in time scales. Another possibility is that it has something to do with what's going on the hard logic side of the SoC, right? You know, in terms of the handling of the DMA operations. And unless we figure out exactly what's going on there and replicate that in simulation, in terms of the timing or reordering or whatever is going on, you might not be able to replicate it in sim. So I'm not sure what the most appropriate, you know, next step is for that. I think probably if I was working on this on my end, I would probably try to drop an ILA on there and see if and just
obviously
and just look at what's going on the AXI interface. It could be immediately obvious, like, oh, that's not right. But it's also possible that, you know, it won't be.
Yeah, I mean, we already did that. I think we already talked about it. We had an ILA in there.
Oh, okay.
And basically the problem was was nothing obvious, at least nothing obvious to Andreas and to me. The exit transfers looked fine. I mean, there was no being not ready all the time. We saw that once, but couldn't reproduce that. All the hangs we saw so far with an ILA is just, well, MQNIC seems to be idle, doing nothing. And nobody blocks by saying T-ready equals 0.
Right. Well, I guess there may be some internal signals that we can pull up. I'll take another look at the DMA modules and see if there's a handful of internal signals that you can pop up on the ILA as well. The nice thing about the Xilinx tools is you can pretty easily do hierarchical connections to various things in the design. So you can add a you know, an ILA at the top level and then drill down to connect it to a few internal signals without having to, you know, thread those signals up by modifying all the modules. So yeah, that'll allow you to pretty easily monitor some internal signals. So I'll take a look at that and see if there's some stuff that can be monitored. You know, when it's hung, just look at these signals and see, are they 0? Are they non-zero? You know, what are they showing?
Yeah,
and just
basically we
so.
had the custom DMA interface in the ILA. We had the simple Axi-Lite register interface in there.
Right.
What else did we have?
Yeah, it's like that's
whole 2 pages of signals. Was a lot, and so far nothing obvious so far.
Right. Well, so here's another thing that you guys can do from Vivado. You should be able to export, you know, a VCD file of the ILA capture. You're more than welcome to send that to me, and I can take a look at it, right? Because I can just open that up in the waveform viewer and take a look at it.
Yeah, sure. We'll do that. Yes.
Especially once once we've reproduced the hang and actually captured it on the ILA, it'd be great to take a look at that and try to get to the bottom of what's going on. Obviously, if we can figure out what's going on, if we can find a way to replicate it in simulation, that would be great. It may make sense to take a look at the simulation models and see if potentially we can implement some, you know, non-ideal behavior. Mainly, I'm thinking in terms of reordering. It should be tolerant to reordering, but I guess it's possible something was missed in the DMA engines. I'll take another look at that actually on my end and see if I spot anything obvious.
Yeah, I kind of wonder every couple of days, what could it be that it only happens in case of too much bidirectional traffic?
Right, because it's, I mean, so the thing is, it's like if you're just sending or you're just receiving, there's still bidirectional traffic going on through AXI, right?
Yeah,
Because it's
yeah.
doing reads and writes. It's got to transfer the descriptors of the completions as well as the actual packets. And you're not seeing it if you're running like iPerf, right? I mean, you can run it. Can you run a 10G line rate with iPerf just in one direction?
Well, what I'm doing is using iPerf in UDP mode.
Okay.
So that essentially makes up just one direction, because only at the
Okay,
end
I see.
the results are communicated from the server to the client.
Right. Well, what kind of bandwidth are you getting with iPerf?
Was not a great bandwidth, I guess, between 1 and 2 gigabits. But that's kind of the what is expected from.
I mean, it's an ARM, so
Xilinx. Yeah,
it's not a very
from
powerful
using
SoC. So
right, yeah. And on the other hand, IQ balancing is not enabled by default, or does not work in the Peta Linux, which is, yeah, unfortunately, but that's the way it is. And of course, to have really max it out, you need to have multiple processes, not just one iPerf on this ARM, multiple iPerfs, multiple processes at least. And then, of course, also have IQ balance working. Otherwise, the whole multi-queue thing doesn't make any sense.
right.
Yeah, we didn't go that far to kind of fix that system setup issue.
Well, you got to figure out why it's hanging first.
Right.
Yeah, I was just wondering what kind of performance you're getting. Okay, so you can run at about a gigabit per second.
Yeah,
but with the pinging,
it was
that's
a little bit lower than what we saw from using Xilinx, the Xilinx 10G, how it's called, the IP core from Xilinx for 10G. I guess we had a
did
higher
they have kind
bandwidth,
of a reference design for
there.
for 10G?
A reference design, I don't know, but they have this 10G IP core.
They also have a reference design, actually. Joachim, that's what we call the software reference platform, which is actually a Xilinx design.
Right. Okay. So we took that from a reference design. Okay.
So I guess that their 10G core is like a combination of the AXI DMA and their 10G Mac, I think, right?
Right. Yeah.
Yeah,
it's that combination, the Mac plus those DMA engines, for one for RX, one for TX,
and some driver stuff.
Right.
Obviously. Yeah.
Well, potentially we have some optimizing to do, but I guess we got to get the hang squeezed out of there first before we can spend any time optimizing. So yeah, okay. Well, I mean, but you guys have made a lot of progress in terms of being able to build it and run it on there, so that's good.
Yeah, I guess also one of the next kind of trivial steps is to rebase the branch we pointed to in the GitHub post.
Right.
Rebase
yeah,
it
you guys pulled in like that that archive that I sent you and whatnot, and that's all been committed upstream now. So yeah.
So we rebase that on the current master to before we continue with anything.
Right. Okay. Get all of the Git history and whatnot all cleaned up. Yeah.
Right.
Exactly. Yeah, we are still also, I guess, leaving the MPSoC area, still working on the Intel side. So there, we think there are still some RAMs in the design that seem to be inferred not the way they should.
That would not surprise me. I went through and I think I got a lot of them. So the main problem that I was having is more timing, and because the RAMs, the block RAMs versus the M labs have very different timing performance. So in some cases if it's not inferring a distributed RAM, then the timing is just terrible. So yeah, I fixed all of the ones to the point where timing closed, and I think I marked everything for, you know, MLab inference and whatnot, but it's possible I missed a few. So
No,
if you're going from a
actually, the
resource
interesting
consumption
part
perspective,
is different. You reference them as MLab, but the tool shows them as they are being implemented in block RAM.
right? Yeah,
So that's a bit strange, and for us it's especially bad because that overfills our BRAM resources in our small device. But anyway,
right. Well, at
so
least
we
you
are
guys
looking into
can
this as
run the
well.
tools now and see how it works. So
Exactly.
if you guys, you know, have any changes that need to be made, I mean, feel free to
Yeah.
open up pull requests against the main repository, and we'll see about getting all that
We
merged
do.
in. So
Yeah, we will do it once we actually figured out what the tool actually does. So it's at some point it works, and at other points it just does something else.
yeah.
So we are not sure actually yet what it really needs to have in place to do and infer what you actually wanted it to infer.
Well,
So,
so it might be time to tap some of the support people at Intel. Right?
Yeah,
because they said
we
they might
do.
be able to help with some of this stuff potentially. So
yes.
now that we have a design that can actually build and run on at least one of the chips, maybe they can help trying to figure out what else might be going on there.
Yes.
They can help as soon as they install Linux to build the design.
Oh, they're running Windows on their end. I see.
It seems so. Well, however, so we got some tips already. We are checking those out. So we are kind of ping-ponging back and forth iteratively. So let's see where this actually ends up. And once we are having something in place, we will provide a pull request and see that this can be pushed upstream then.
Right. Okay.
And the other item is our embedded end going into the 1 gigabit direction. I guess Joachim, I think we should finish up our internal review and push this to GitHub. So we did a 1 gigabit SGMI based port for the ZCU 106. So you could actually plug SGMI 1 gigabit modules and use those. I don't know. So this currently uses the Xilinx IP core, the SGMI PHY,
right,
which uses the transceivers. I guess your approach is to do less as possible based on third-party IP cores, right? So it kind of contradicts this this idea. But
no, so for the board level stuff, if you need to use third-party IP or Xilinx IP, you know, I mean, that's fine, right? It's in the core logic. I'm trying to keep it out.
Yeah, that makes sense.
So
what
like the
want to
net
say
FPGA design, for example, that uses a Xilinx PCS PMA cores for 10G, because my PHY core doesn't currently support the transceivers on that chip. So
I see. Mm-hmm.
So yeah, that's fine. Well, and for all the 100 gig stuff, I'm using the Xilinx CMAX. So, you know, you got to do what you got to do.
Yeah, that really makes sense. Otherwise, you would need a half of a chip just doing the Mac. Well, I guess, but there is in your Ethernet repository, we saw that there is an SGMI implementation there, I guess, for LVDS pins. So
right, yeah. So I don't have any SGMI stuff myself. All of that stuff is going to be used in the Xilinx IP.
Okay. So this is basically an instantiation wrapper.
Yeah. All the example designs in there. I don't have any. The only PHY IP that I have is for 10 gig. I don't have anything for 1 gig. Right. So it's just GMII or MII or whatever to an external PHY chip, or then Xilinx does have the SGMI PCS PMA cores, and they, depending on the chip, you can use them either with the SerDes or with the LVDS pins, depending if the chip is fast enough. But word of warning,
Right.
there's some really weirdness about pin selection for doing that. If you're doing the LVDS from the IO. It's
Is
really
there a
screwy.
GTH transceiver there?
Yes.
A GTH transceiver where?
In your chip, I mean.
Yes. So there is one, and we are using this for SGMI as well.
Oh, okay.
Right. Yeah. So that's on the ZC106. So the SFP plus cages on there are driven by GTHs.
Exactly.
I think. Yeah. That one doesn't have
Yes.
any GTYs. I don't think.
and
I
there is
think
another approach.
GTH is also similar to GTY, right? And
Yeah,
they
there's some
have
minor
a lot
differences.
of things
Biggest difference is the
in
speed.
common.
But
Yes,
I
of
was
course,
thinking
but
it's
in 10G, it's okay, I think.
right. So
Yes.
GTY I think is good up to 28 or 32 gigabits per second, something like that. And then the GTH
Yes.
is good to like 12 and a half or 16.
Yes, yes.
I don't know.
And there
Depending
shouldn't
on
be
the
any
line of chip that
problem
you have
at,
and whatnot. Yeah.
there shouldn't be any problem at 10G, I think. So
Yeah. No, I was just thinking it's an ultra scale plus. So a lot of those have the GTYs, but I guess not not the ZC106. I guess it's a slightly lower end part. So they have the GTHs instead of the GTYs.
okay.
I guess you need at least an 11, I think, and then you could get GTYs in the larger packages.
Right. Which zinc chip were you guys going to be using? Is it one of the smaller ones, presumably the MPSoCs?
So I guess we are most probably targeting a ZU9.
Okay.
So it's the
One step up
the
from
standard one, the ZU102 standard device, basically. I guess
okay.
everybody
I see.
knows this device. Exactly, yeah. But yeah, for testing and especially upstreamable testing, we use the ZU106. And we have
Well, so I
another
also have a
device.
102. So if you know, I could certainly test stuff out on there. Unfortunately, that one doesn't have PCIe on it, so that's
Right,
why I don't
exactly.
have a
So
design for the 102 because you know that has to run on
yeah,
the
but
actual SoC.
I guess it really makes sense once the MPSoC integration is working to have a design for the ZU102 because it's very, very popular. Even
Yeah.
actually every university has at least one, maybe 10 or 20 of it.
Yeah. So once we get it working on the 106, then we can certainly, you know, port it to the 102. Do you guys have a 102 or?
10, 20, no, 12, I guess.
Oh, you have a whole
I
bunch of
don't
them. Okay.
have. I don't have.
But some of them you don't want to use because they are, I don't know. No, we don't have pre-production silicon anymore, but we do have pre-Rev1 boards.
Oh, so the board's gonna have some funky stuff going on.
Yeah.
I see.
But most of them
Which,
just work.
I have a Rev 1 of the one of the Kintex 7 dev boards, and the P and N pins are swapped on the SFP. It's kind of annoying.
Oh, that's an interesting feature.
At least it's mentioned in the datasheet.
Okay, so don't use this if you want to use the SFP. Nice.
Well, so the annoying thing on there is that swapping them is not bad. You just have to pull out the polarity invert pins on the transceivers and flip those. But if you're using like the PCS PMA PHY IP core, they don't have an option on like a per pin level. They just have like bring out additional pins, and it brings out like 500 pins or something. And then you don't just have to tie those; you have to tie all of the pins now. It's like, oh, it's annoying.
Yeah, that's right. Yeah.
But okay, so that was not too bad because it's documented. The more annoying
Yeah,
one
right.
are we got some of these Exynic X10s that some of the first boards that we tried to get Corundum running on, you know, were these guys, and either the TX or the RX are pin swapped on here. So yeah, this provided a few hours of head scratching when I was trying to get the Ethernet design working. It's like it says there's a link, but I can't send or receive any data. It says there's a link because it doesn't matter actually if the it's looking for the sync header, and the sync header is just either 0, 1 or 1, 0 depending on whether it's control or data. So if you invert the whole thing, it still gets a block.
yeah, that's that's the board features. You really need time to
Yeah.
find them
And
out.
for that one, I didn't have any documentation aside an XDC file. So it took a bit of head scratching to think, well, maybe they flip-flop these for some reason, for layout reasons. So I'll just try, toggling the polarity invert pins and we'll see what happens. And I managed to figure it out, but it was like, geez, would have been nice to get a heads up from those guys, but
Right. Or some comment in the XCC file in the reference here.
their
Pin
XDC file was
swaps.
very sparse.
I imagine there are PCB providers out there that think that providing proper pin out is I don't know, crazy, yeah, really strange. So how they think one should use their PCBs.
Yeah, go figure.
Okay, so I guess I need to run.
All right.
But that's hopefully the last time. So this meeting afterwards, after our dev meeting, will be moved soon. So I don't have any hurry anymore for the next meeting.
All right.
I want to tell you one thing. If you want me to deal with GTH, I will happily do that. I will try to learn and connect. Maybe I will connect it to XGMII interface, GTH transceiver to XGMII interface. I will try to solve it. I think there is no much change in the code. So.
What are you referring to?
I'm not familiar with GTH transceivers, but I am familiar with GTY, and you are too busy, I think. So if you want me to deal with, to solve the problem with GTH, I will design a module which is just to connect the same thing to GTH transceiver. So Corundum will support GTH at 10G, for example.
I think we already have Corundum designs running with GTH at 10G.
Really? Yes.
The ZC106, I think, right? That has GTH, and then we have a reference design for that at 10G.
Okay, then no problem.
Yeah, I mean, if you're not doing anything particularly weird, GTH and GTY are pretty much just drop-in replacements for each other.
Yes.
The problem with like the NetFPGA Sumi, I can't remember what that might have technically GTH transceivers on there. But the problem is they don't support the same gearbox mode as the newer ones. So on most of the designs, I use what's called the asynchronous gearbox, where the FPGA side runs at 156.25 megahertz. And that's just a little bit easier to work with. But for the 7 series, they only support the synchronous gearbox, where the FPGA interface runs at 161 point something megahertz, and not every transfer cycle is valid. So you have to insert stalls.
There is one invalid cycle.
Right, every so many cycles. So I need to update the PHY modules that I have to support some sort of a, enable signal or something. I haven't done that yet because I'm not sure exactly, what's going to be the cleanest way to implement that. So at some point, I'll probably do that, but it's not a high priority because, all the current parts support the async gearbox. And if I need to run on one of the other parts, I'll just use a Xilinx, PCS PMA module. So yeah, there's a couple of reasons that I'm using my own PHY modules. And I think a big one is for some of the circuit switching stuff that we're doing, we need to screw around with the frame synchronization code to try and speed that up. And it's much easier to do that with my code than with the Xilinx code, I think. So, but yeah, other than that, there's, yeah, I guess you might as well just use the, yeah, other than that, if you're running on like on a part that the Ethernet code that I have currently doesn't support, it makes sense just to use the manufacturer provided stuff, unless there's some weird licensing thing. Like I was running into some issues. To be honest, I've never really run into many issues with the 10G stuff, but with the gigabit stuff, I've run into some weirdness. So we have like a bunch of Cyclone 10 GX dev boards, or I guess a bunch, and we have 2 of them. But the Intel PHY IP for gigabit requires a license. It's like, really? You need a license just for the PHY IP for SGMII? That's kind of lame. So yeah, 10G, and I was running into some issues with 10G interfaces on those anyway. Bit error rate problems. I need to like adjust some sort of setting, but it wasn't clear what I had to do, and that's been tabled for a long time. So maybe we'll circle back around to that at some point, but I don't know. Got bigger fish to fry, I think, for the time being. But yes, so everything works with both the GTH and the GTY on the UltraScale and UltraScale Plus devices. So, I mean, if you want to learn how these things work, you know, that could be a good exercise.
Yes, sure.
But yeah, for the most part, I just use the transceiver wizard and then wire things up accordingly. So, and from that
I
standpoint,
also,
the differences are very minor. I think there's like a, I think the GTYs support a slightly wider internal data path width than the GTH, which you need for running at the higher line rates, and that
maybe
has some clocking that has some clocking implications in terms of how the I think for the GTHs at 10G you need 2 internal clocks instead of 1 because the widths are different. It's like 32-bit internal, 64-bit fabric interfaces. So the internal clock is at 300 something megahertz, and it needs another clock buffer or something. So minor differences, but yeah.
yes. I think there should be minor difference because their document. I haven't read the document for GTH because in our FPGA we only have GTY, but I remember that once I scanned the GTH, it looked similar, I think.
Yeah, the GTY is just a, you know, newer upgraded version of the GTH basically. So supports
And
running
we
at
are
higher line rates, but otherwise has very similar features.
in threading, we are doing something like we are using synchronous gearbox with buffer bypass. So
Oh, right.
because
Yeah, if you're trying to do super low latency, then yeah.
Yes,
there are
so
tricks you
it
can play.
becomes like old style.
Yeah, just to make things more annoying.
Yes, you have to wait 1 cycle doing nothing.
Yeah. All right. Well, I guess you might as well close down for today then, if there's nothing else that people need to discuss, right? You guys are
Do you have a
Emily,
question, Joachim?
No.
Yeah, it's like it sounds like the MLE guys are are good to
Joachim,
go at this point. So.
am I telling your name in the right way? I mean, am I spelling right? No, not
Yeah,
spelling. What was
perfect.
that? Oh, really? Yes. Thanks.
All right.
Okay, see you next
see you guys
week.
in 2 weeks, and it looks like you're on the Slack
Yes.
now. Oh, speaking of which, does
Next
that link that
square
I sent work, right? For the
yes,
first link
yes,
that I
it
sent?
worked.
Okay.
I tried that link, and now it worked.
Okay, so you got the list with the all the steps.
Yes,
Okay.
yes, that was what I was asking for. Similar
Sweet.
to...
Yeah.
There is no major change in that steps right now, right? Do you think?
There's a few kind of minor changes. I mean,
If I learn that,
so as the design progresses, there's a few things that are going to be changed, but the general flow is going to be similar. There are going to be a few kind of minor differences. So
because if I learn high level, it will be easier to understand the codes.
Yeah, yeah. Like I said, even if there's pretty significant changes, that's still going to be, you know, at least a high level reference. So
yes.
Yeah. All right. Well, that's good to hear. I figured I would confirm before getting off the call because, you know, it closes the chat box and everything. So
yes.
Yeah.
And link will be lost.
Yes. All right. Well, in that case, I think we're good to go. So we'll see you guys in 2 weeks then, right?
See you.
See ya.
Bye.
See ya.